In set theory, the union of a collection of sets is the set of all distinct elements in the collection. It is one of the fundamental operations through which sets can be combined and related to each other. Union of two sets. The union of two sets A and B is the set of elements which are in A, in B, or in both A and B. In symbols, for example, if A equals 1, 3, 5, 7, and B equals 1, 2, 4, 6, then AB equals 1, 2, 3, 4, 5, 6, 7. A more elaborate example is A equals X is an even integer larger than 1, B equals X is an odd integer larger than 1. Sets cannot have duplicate elements, so the union of the sets 1, 2, 3, and 2, 3, 4 is 1, 2, 3, 4. Multiple occurrences of identical elements have no effect on the cardinality of a set or its contents. The number 9 is not contained in the union of the set of prime numbers 2, 3, 5, 7, 11, and the set of even numbers 2, 4, 6, 8, 10, because 9 is neither prime nor even. Algebraic properties. Binary union is an associative operation, that is, A equals C. The operations can be performed in any order, and the parentheses A may be omitted without ambiguity. Similarly, union is commutative, so the sets can be written in any order. The empty set is an identity element for the operation of union. That is, A equals A for any set A. These facts follow from analogous facts about logical disjunction. Finite unions. One can take the union of several sets simultaneously. For example, the union of three sets A, B, and C contains all elements of A, all elements of B, and all elements of C, and nothing else. Thus, X is an element of A, B, C if and only if X is in at least one of A, B, and C. In mathematics, a finite union means any union carried out on a finite number of sets. It doesn't imply that the union set is a finite set. Arbitrary unions. The most general notion is the union of an arbitrary collection of sets, sometimes called an infinitary union. If M is a set whose elements are themselves sets, then X is an element of the union of M if and only if there is at least one element A of M such that X is an element of A. In symbols, that this union of M is a set no matter how large a set M itself might be, is the content of the axiom of union in axiomatic set theory. The idea subsumes the preceding sections, in that ABC is the union of the collection A, B, C. Also, if M is the empty collection, then the union of M is the empty set. The analogy between finite unions and logical disjunction extends to one between arbitrary unions and existential quantification. Notations. The notation for the general concept can vary considerably. For a finite union of sets, one often writes. Various common notations for arbitrary unions include AND, the last of which refers to the union of the collection where I is an index set and is a set for every. In the case that the index set I is the set of natural numbers, one uses a notation analogous to that of the infinite series. When formatting is difficult, this can also be written A1, A2, A3. Whenever the symbol is placed before other symbols instead of between them, it is of a larger size. Union and intersection. Since sets with unions and intersections form a Boolean algebra, intersection distributes over union, and union distributes over intersection. Within a given universal set, union can be written in terms of the operations of intersection and complement as where the superscript C denotes the complement with respect to the universal set. Arbitrary union and intersection also satisfy the law